It's appropriate that we gather in Houston. It's the hub of the U.S. oil and gas industry, most of which takes place here, the activities in the United States waters of the Gulf of Mexico. Now, last year, our 2014 conference was a huge success. Last year, the Gulf of Mexico Oil Spill and Ecosystem Science Conference was held in Mobile, Alabama. So welcome back if you participated in one or two of the first conferences. If you're new to this conference, we're very pleased that you've joined us. Now, last year, there were 900 people registered. This year, we're closing in on almost 1,000 participants. We have 203 students, a very valuable part of our attendance at this conference. They will share their research in talks and poster presentations. It's really amazing. This year, registration represents 21 countries, 35 states, District of Columbia, and more than 140 universities and many federal and state agencies. And very welcome to 80 companies who are represented at this meeting, along with some of the NGOs. And also attending are citizens who walk in to attend because they're interested in our work. So there's a very special welcome to them also. Now, there have been about 550 abstracts accepted for the conference. We'll be here for 2.5 days, concurrent sessions, with about 270 oral presentations and 240 posters in 2 of the poster sessions. Now, last year's meeting included a memorable ice storm that locked in some participants for an extra day of festivities. I think a few felt they checked into Hotel California. They couldn't check out. But this year, we seem to have weather problems as well on the East Coast. We're here nice and comfortable, but some of our colleagues are under several feet of snow. Most of our speakers, thank heaven, have made it to the conference, especially our keynote this morning. Now, the goal of this, the 2015 conference, is to focus on oil spill and ecosystem science research results that have been gathered over the last 5 years since the Deepwater Horizon oil spill in 2010. This year's conference seeks answers. What scientific questions have we answered? How can we apply our findings to a very important environment in the Gulf of Mexico? So the emphasis is on impacts of the research and application of our research findings. Our 13 sponsors deserve special thanks. They're listed in your program. They make this expanding and excellent scientific forum possible. I especially want to thank as well our executive committee and our superb staff for their incredible organizational skills that's evidenced in how well this conference is proceeding. And then I would also like to thank the National Academy of Sciences. Their Gulf research program has provided funds to support the very well-attended training session for graduate students that was held yesterday. And they're also feeding our students. They're providing lunches this week. So to the National Academy, our partnership in this endeavor, thank you very much for your support. Just a few descriptors of the conference. The closing plenary will include reports from the session chairs that will highlight the discussions in those sessions. And this morning, we are indeed honored to have our introductory plenary address given by Rick Spinrad, the Chief Science Advisor for NOAA. After Dr. Spinrad's address, there will be the 8 of the original research consortia leaders from the first round of funding who will tell us what's been accomplished to date in their endeavors. But now, it's my sincere and genuine pleasure to introduce a really good friend, a colleague for whom I have the deepest respect, Dr. Richard Spinrad. Rick was appointed by President Obama as chief scientist of the U.S. National Oceanic and Atmospheric Administration, NOAA, in May 2014. He's an internationally recognized scientist, a very successful executive. He's got about 35 years of experience in government, the private sector, academia, and also non-governmental organization. As a result, he has a very clear understanding of environmental research, especially oceanography, as well as management, and he's also an experienced teacher. Prior to joining NOAA, Rick was Vice President for Research at Oregon State University, and earlier he had served as head of NOAA's Office of Oceanic and Atmospheric Research, as well as the National Ocean Service. Rick is a leader in developing the nation's first ocean research priority strategy, and also now in leading us in research at NOAA. So, Rick, I welcome you to the podium.
Thinking back to our meeting in Mobile, some of us spent more than an extra day in Mobile last year. And in fact, I see Bruce Mate in the audience. He and I got to know each other very well over those 3 days, trying to find some place to eat in the town. And the important point now is if you look at what's happening here in Houston, and I would also point out that Mobile is going to experience sub-freezing weather here today as well, that I've concluded in my capacity as chief scientist at NOAA that we need to build in the scheduling of the Gomery Conference in years to come as part of the weather outlook portfolio that we use in the National Weather Service. It's obviously a very reliable correlation and causation indicator. So let me start first by adding my thanks to those that Rita shared with you here, and also thank Chuck Wilson and his team for the work that they have done in pulling this together. This, of course, is a critical conference in terms of getting the leading-edge scientific results out in front of the public, in front of a broad community. I was particularly impressed last year with the diversity and, if you will, transdisciplinary nature of the research results that were shared, and undertaking a dedicated and specific focus on communicating these results to a diversity of user communities. That, I think, is an essential activity for promoting long-term science in the Gulf. I'd like to take the theme of this year's conference, namely, what have we learned, what does it mean, and how can it be used, and try to put an emphasis on the impact of the research and applications of some of the published research findings. And perhaps what would be helpful is to do this first in the context of NOAA's scientific portfolio. Let's try using this key. There we go. And some of you may have seen this concept for laying out NOAA's view of moving forward and our role and responsibility. NOAA is the nation's environmental intelligence agency. What does that mean? It means that we provide the timely, actionable, and reliable science-based information that citizens and communities and industries need to stay safe and operate efficiently. And that science-based information is what makes NOAA into a science-based services agency. The cornerstone of this work is perhaps NOAA's most distinctive niche among all federal agencies, and that's the capability for practical prediction and projection. NOAA's ability to deliver this kind of environmental intelligence starts with keeping the pulse of the planet, especially the atmosphere and the ocean, through our monitoring and through our observational activities. This environmental intelligence provides us with some powerful situational awareness and equally powerful insight and perspectives into the condition of the environment around us. Perhaps even more importantly, environmental intelligence provides us with the foresight, the ability to look ahead and to anticipate future conditions, and of course then assess what the alternative courses of action might be to make our society more resilient and better prepared. During the Deepwater Horizon, we saw this in the form of the oil trajectory maps, the spot weather forecasts, the overflights, and the science that helped us at the dawn of the spill and continue to provide foresight in the future. Producing that kind of environmental intel requires observations melded with some sophisticated Earth system knowledge, and of course modeling developed through decades of research. To be useful and used, it also requires effective communication. And I'll say a few words about how I think what's going on here with Gomery-supported activity is a model for how that communication is undertaken. And the centrality of this environmental intelligence is relevant in 4 of our agency-level priorities, one of which is to provide the information and services to make our communities resilient. It's also about evolving the National Weather Service to make us a truly weather-ready nation. It's about investing in observational infrastructure, and I want to make sure this audience understands that's not code for our satellite activities. And when you look at the press, there's been a lot of attention to the investments, the dollars spent on the satellite infrastructure that we've got, which of course is critical to all of the work we do. But it's also as much about ships, planes, gliders, buoys, water level gauges, AUVs, et cetera, all of the things that I think every one of us in the audience considers central to the concept of observational capability. And then the last emphasis that you see on this slide is on organizational excellence. And that's one of the things that I hold near and dear. One of my main jobs at NOAA is to try to build a robust portfolio logic for our research. Why do we spend the money the way we do? Why do we invest the way we do in extramural and intramural? What are our priorities if one additional dollar comes on the table for research? Let me expand a little bit on this resilience priority and talk to you about some of the concepts associated with our view of what resilience really means. And so when we talk about resilience at NOAA, we're talking about the economic, social, and ecological resilience. And all three are intertwined. And of course, obviously here in the Gulf, Deepwater Horizon is a brutal reminder of these very interconnections and the immediate consequences of the spill. Closure of the fisheries robbed fishermen of their livelihoods. Production decreased by at least 20%. Approximately 1,100 linear miles of coastal wetland were affected by the Deepwater Horizon spill. Vacationers abandoned the region for some time after the spill, and the daily lives of coastal Gulf communities were put on hold. All of these emphasize that intersection of the social, ecological, and economic consequences. And underpinning everything that we do at NOAA is the science. Like I said, we are a science-based services agency. So let's look at how the science was made available to the public during Deepwater Horizon. From some of the earliest days of the spill, NOAA and our partners made a commitment to sharing as much of the information about the spill response and the natural resource damage assessment associated with it that we are collecting as soon as possible. Today, we recognize that Deepwater Horizon has the most transparent process in the history of the natural resource damage assessment. NOAA first announced its decision, with Jane Lubchenco as the administrator, to make NERDA data publicly available at the Coast Guard-hosted second large-scale science meeting that many of you were part of. More importantly, and more explicitly, that decision was to make data collected under cooperative studies that had undergone quality assurance and quality control available to the public after a 7-day wait period. The release of the QA/QC data was unprecedented in the history of NERDA. And in fact, what you see here in the top left is the IRMA, the Environmental Response Management Application Tool, which is a web-based GIS tool that assists emergency responders, environmental resource managers in dealing with the incidents that can harm the environment. IRMA integrates and synthesizes the data, some of which happens in real time, into a single interactive map, providing a quick visualization of the situation and improving communication and coordination among responders and environmental stakeholders. IRMA was designated by the Coast Guard as the common operational picture for the Deepwater Horizon response, and it provided access to a wide variety of near real-time data for responders and the public audience. On the bottom, you see the Deepwater Horizon Research and Monitoring Clearinghouse screenshot. And during the spill, our partners in the Gulf, the Sea Grant organizations, provided access to a database that served as a searchable repository of DWH monitoring, research, and restoration activities, and activities were listed regardless of the funding source. You also see on the right side the National Oceanographic Data Center, one of NOAA's data center responsibilities, a national responsibility. And NOAA developed the site, the NODC site, to provide the public with access to the hydrographic, the chemical, the physical, and profile observations that were being collected on various cruises. 115 research cruises were conducted and the data accessible there. And in fact, as you can see on these photos, for the first time, teams of reporters, non-governmental organizations were taken into the field. There's a shot up in the upper right there of one of those folks to observe NERDA field assessment activities with dozens of press interviews granted in the summer of 2010, yielding, as you all know, many stories on national TV, radio, and press outlets. And I would like to believe that the transparency for the NOAA-NERDA process information continues within the constraints, of course, that we are held to with respect to availability of those information. We continue to make the NOAA-NERDA information available. The Gulf Spill Restoration website, as you see on the top left there, provides a flow of some of the peer-reviewed publications that are available. On the right, you see the NOAA Gulf Spill Restoration website, where you'll find the latest information about the NERDA process. So far, over 115 NERDA work plans, 3.8 million individual analytical results from over 53,000 NERDA samples are publicly available on this website, as well as information on how the public can get involved in restoration planning. The analytical chemistry and bioassay data are also collected from the response by EPA, USGS, BP, and academic cruises are all, and all of those data impacting the Gulf states are also available on the Gulf Restoration website, which includes over 2.2 million individual analytical results from over 20,000 samples. On the right side, you see some examples of published work by partners of NOAA and NOAA researchers as part of the NERDA activity, including some of the analyses of the impacts of the oil spill on dolphins and deep sea corals and benthos, and some of the studies on fish toxicity as well. To date, NOAA has found and published on exposure and injury to deep sea corals, deep sea benthos. Some of the induced cardio systems were impacted on developing Newston and juvenile fish. We're seeing results on impacted health on coastal marine mammals, and of course, the lawyers are quick to remind me that the potential litigation prevents us from discussing the ongoing analyses of the data, and I want to make sure everybody understands that so I can keep my job when I go back to D.C. Transparency, along with coordination, communication, and funding, are enabling some of the long-term Gulf science, not just one-off projects, if you will, but coordinated efforts through communication are enabling long-term ecosystem analysis and assessment, informing NERDA now and also, unfortunately, what we know will be future NERDA activities. NOAA, NERDA, and GOMRI have both benefited from each other in the ways that I've just mentioned. And I'd like to give some examples of how the broader point of transparency and communication and coordination are enabling some really stellar long-term studies and some wonderful scientific results that are emerging. Let me first point out that a lot of agencies, and I'll try to be careful to credit those agencies accordingly, have been contributing to this body of knowledge that we've got. And I'll start by thanking the National Science Foundation and their rapid grant program and subsequent funding by GOMRI. We have some, as a result of those investments, we have some better ideas about where the oil went. So this is what I'm showing here, some work by Uda Passow at UC Santa Barbara on the formation of marine snow, an issue which, incidentally, I personally was involved with when I was at the Office of Naval Research almost 30 years ago. So the work that's been done here has a legacy of research behind it, but these findings are particularly important. This work was funded by GOMRI. We caught up with her work at one of the early GOMRI meetings, and based on the work that she was doing, put her on contract with NOAA NERDA. And her work describes a potential sedimentation mechanism that seemingly explained the presence of some of the oily floc deposited in these deep benthic environments. When oil spill samples collected from the Gulf surface in 2010 were incubated with seawater in rotating tanks in Uda's work, she observed the formation of marine snow particles that ranged in size from millimeters to centimeters and would have sunk to the seafloor. Some of the hydrocarbon-consuming microbes naturally present in the water produce a mucus that agglomerates the spill with the oil to produce the snow. But the aging of the oil in sunlight, which promoted snow formation, was inhibited by some of the dispersants. And as a consequence, this dramatically affected the sedimentation rate and the dynamics of those flocks. This work was made possible, as I said, by a grant from BP, from GOMRI, through the ecosystem impacts of oil and gas inputs to the Gulf Consortium. And some of the other sources of funding for this were, as I said, the NSF RAPID program, as well as some additional funds from more traditional NSF funding, if you will. So that's one example of that kind of work. But some of the other issues, we're talking about what's changed, what have we learned, what's changed in the ecosystems. And in this case, this is some work of Chuck Fisher's that basically addresses provides an example of where some of the science funded by either NOAA, NERDA, or GOMRI has been beneficial in terms of developing a better understanding of the natural resource injury and in better understanding of the long-term effects of the disaster on the deep benthic unique systems. And in this case, Chuck Fisher at Penn State and his colleagues developed in a paper that was published in PNAS some evidence of hydroids in two coral communities almost twice as far from the wellhead and in water that was 50% deeper than those that were originally described. Large aggregations of hydroids you're seeing in these photographs on the left side that are generally absent in healthy coral colonies, and instead the hydroids encrusted damaged branches and can indicate overall health of the coral. This is a really good example of some of the initial work funded in part by NOAA NERDA, focusing on assessing the magnitude and the spatial distribution of injuries to the deep water corals. And it's evolved into GOMRI-funded studies looking more broadly at information pertaining to the long-term variability and the resiliency of these organisms. So data gathered by Fisher and his colleagues during the GOMRI-funded cruises in 2012, 13, and 14 have already provided some additional information for the NERDA injury assessment pertaining to the progression of the original observed injuries. And further, we expect that some of the future cruises that GOMRI has already funded will allow Chuck and his colleagues to better understand some of the injury duration and the rates of recovery on these hard ground coral ecosystems. On the right side, you see a map of DeSoto Canyon relative to the wellhead, and the dots indicate some of the NERDA sampling sites. And it's another example of the GOMRI-NOAA collaboration. The GOMRI research informs sampling in the sense that the researchers, in this case at University of South Florida, David Hollander's group, alerted NOAA and BP to the potential impacts to the Deepsea benthos extending up into the DeSoto Canyon to the northeast of the wellhead, which provided some impetus for taking additional samples and extending the sampling regime in that area during a 2014 soft bottom sediment cruise. So there's another example of some of the findings that we've had and the implications, both in terms of scientific understanding and the damage assessment itself. Which brings me up into the question of what might be the effects of the oil on the fisheries. So GOMRI funding extends some of the earlier NOAA NERDA work on potential impacts of oil on developing fish embryos and larvae. And in this case, this was GOMRI-funded work by UC Davis's George Whitehead and colleagues, who looked at genomic and physiological impacts to resident marsh fish in Louisiana, and citing prior NOAA NERDA cutting-edge work, which linked genomic changes to physiological impacts of developing cardiosystems within some of the various fish larvae. And this was work that was collaborated with some of our researchers in John Incardona's group at the Northwest Fisheries Science Center at NOAA. And the work draws conclusions that demonstrate some of the in situ occurrence of these impacts. This research, Whitehead et al.'s research, was supported by grants from National Science Foundation, GOMRI, NIH. The GOMRI-funded work continues to inform NOAA NERDA work. For example, contributes to refining our understanding of the many different injury mechanisms that we might expect, and our understanding of how some of these seemingly disparate results may be linked through ecosystem feedbacks and loops. And an important element of the transparency and straightforward access to data that I alluded to is addressed here. The question then is, looking forward, what kinds of things can the science community do to promote some of this transparency and visibility of these kinds of results? So I want to shift gears a little bit here and talk about some of the tools and concepts that are being developed for making information, data, dare I say environmental intelligence, available to broader communities. There are two new tools that will soon be providing access to these data. GOMRI has been hard at work on Deepsea, the Gulf of Mexico Research Initiative Information and Data Cooperative, which is going to assist researchers with data archiving and will ensure the data interoperability. A critical aspect, of course, is with these millions of data that are being collected, how can we ensure that they are interoperable and applicable to a diversity of different questions, decisions, applications. GridSea is designed to receive and process data from a wide range of sources and disciplines, and that's an important point. I can tell you as an oceanographer, one of the big challenges has always been throughout my career ensuring not so much that the data are available, but that they are interoperable across what unfortunately have been some hard, bright red lines in the communities and the disciplines of oceanography. So this is a major step forward. We at NOAA are very excited to be releasing very soon. I was hoping I could make an announcement here today. I can't do that. There are a number of people in the audience who are listening very carefully as I go on the next couple of steps talking about Diver, which is our data integration, visualization, exploration, and reporting tool. It's going to vastly improve access, delivery, and analysis of some of the NERDA data for the public. So those of you who are wondering about availability of the data and access to the data, it is imminent. The release of Diver is imminent. I just had a Diver demo last week, and I really was blown away. And I would recommend, if you're interested in this, stop by Ben Shore's talk this afternoon in the session on data management, informatics supporting ecosystem sciences. And you'll get to hear a lot about the nuts and bolts associated with Diver. The Diver suite of tools contains data models for some of the integration and standardization that I talked about. And the data warehouse incorporates environmental intelligence, again, a set of techniques and tools for the standardization and transformation of raw data into meaningful products and services, I would say, as well. And like I said, we will have a public version of this released soon after this conference. So we've discussed research results. We've discussed some of the data. Let me shift gears again now and talk about one of the very important aspects of what we do, and that is getting the word out and communicating. And I mean that in the full duplex context, that is two-way communication with and from the communities that are interested. And I want to call out a number of people. I assume several, if not all of you, are here. Here are the people who are turning our science into plain English and reaching out to folks who need and want more of the oil spill information. These smiling faces are the new Gomery-funded Sea Grant oil spill extension specialists in the Gulf, and they're working to investigate and disseminate information on the effects of spills on ecosystems and humans and understand the fate of oil in marine spills. The four new Sea Grant oil spill specialists and their director represent a brand new model of public-private partnership, one that I think we will be looking at very carefully in terms of effectiveness in reaching across communities. It involves a large private funding entity through Gomery. It's funding a regional Sea Grant program comprised of 4 Sea Grant college programs. The fellow on the upper right, Steve Sempier, is the program manager. We've got Larissa Graham from the Mississippi-Alabama Sea Grant. We've got Monica Wilson from Florida Sea Grant, Emily Mong Douglas from Louisiana Sea Grant, and Chris Hale from Texas Sea Grant. Just out of curiosity, are you here? If you're here, there you go. Okay, a couple of you. I look forward to meeting you later and find them during the conference. Talk with them about what they're doing. We could probably go into great detail about a lot of what they're working on, but it's tied to some new tools, and I want to talk for just a minute about one of these tools. This one, which I'm sure you can all read in detail in the back of the room, is in fact a sociogram. Now, I'm not a social scientist, but one of the important things is that the program is smartly using social network analysis to design and understand the reach of the program on communication of oil spill science and also get a sense of what the needs are from a variety of communities. So there's a paper by Steve Sempier and Chris Ellis, and LaDon Swan that has come out talking about this. And basically what you need to understand is that this sonogram was developed from extensive surveys with a number of different communities in the Gulf, and they represent the nature of the communication tools. So the nodes if you will. The bubbles are people, and the lines are relationships. And the node size reflects the degree of, if you will, credibility, reliability, timeliness of information communicated. And it turns out that when you do this kind of social network analysis, a number of results come out. So, for example, what we've learned from this is that the people appear to seek credible, relevant, and timely oil spill information from a number of sources, including federal agencies, academia, Sea Grant, and that these are the trusted agents. There's a lot more detail, obviously, to the results here, but it's important to understand what tools for communication are important and what relationships are those that need to be cultivated, studied, analyzed, and attended to accordingly. So this is going to be very important as we move forward, as we understand what opportunities lay before us, as we determine what routes we're going to take, what processes we're going to take. And I'd like to spend just the last couple of minutes talking about some of these opportunities. And these opportunities are kind of a mixed bag. They represent a variety of different approaches. Of course, this is just one slide on the Restore Act, the Restore Science Program. This funding there was a funding opportunity announced, the first funding opportunity announced in December. And of course, part of the Restore Act is to develop a science plan with funding opportunities to increase our understanding of the Gulf of Mexico. So this first competition, if you did not already participate, this is not a new opportunity for you, but I suspect just about everybody in this audience was aware of this and has had the opportunity to submit letters of intent. Those were due back in January. We received more than 100 of these, and we'll be providing somewhere between $2 and $2.5 million for research that addresses some of the short-term priorities that you see here, as well as, and those are in the areas of inventory and assessment, development of indicators, and determining what monitoring needs we have. The topical areas, not surprisingly, are associated with marine resource management, the effects of climate change and weather on sustainability of restoration activities, and of course the integration of social sciences, not unlike what I just alluded to in my previous slide. Some other opportunities, this one is a little bit different. This is a nutrient sensor challenge. This particular challenge is being managed by the Alliance for Coastal Technologies. It was coordinated by OSTP, or OSTP coordinated a public-private collaboration to bring some open innovation and challenge prizes to bear on improving our nutrient observational capabilities. This will, of course, stimulate, I believe, a lot of activity. Some of you may know that there's interest in groups like the X Prize in developing similar sort of sensing capabilities. So go ahead and check the website here, and I assume these slides will be made available for everyone. And register if you're interested. There's still time to register and develop a capability. And on a broader basis, going out to things that are not quite as imminent, but are of an equal impact and certainly have a, I would say, a much broader user base and community involvement. The development of a national climate indicator system, and this, of course, is a natural follow-on to the issuance by the President of the National Climate Assessment, is an area that's receiving a lot of attention right now. And the exciting part of this is that I think everyone realizes we have an opportunity to develop a rather expansive set of climate indicators. And the really exciting part of this is that there's been, I think, a fundamental change in the perception of how citizen science can feed into this. And consequently, you see an email address, you see various programs like Zooniverse identified here. The message I'm trying to convey is keep in mind that as our nation moves forward in developing sustained and robust programs associated with dealing with climate change, the portfolio of indicators that we use will become much more diverse. We have an opportunity here with all of the work that's been Montgomery funded and all the work in the Gulf of Mexico to try to identify what is the appropriate portfolio of climate indicators and actually engage some of the communities. And if you go back to my previous social network slide and the role of the Sea Grant specialist, we have an opportunity to build a very different and I believe much more impactful citizen science component to that particular activity. There are a couple of other areas that I would say are going to be receiving attention in the future, and I won't say a lot about them, except simply to point out that one of the things that has risen to the top, if you will, in terms of attention to how we deal with natural disasters is the role of green infrastructure, natural infrastructure. So there is a White House task force that is in the final stages of producing their report on how we should move forward on development and investment in green infrastructure. I have got to believe that so much of the work that's been done here in the Gulf, so much of the Gomery-funded work contributes immensely to an understanding of the role, the benefit, the impact, the balance, the cost-benefit analysis associated with green infrastructure that has happened here in the Gulf will play integrally in the development of what some of us fondly call response to the White House recommendation number 22 from that task force. And so whether we talk about restoration science, sensor development, and I put here as a placeholder a lot of the attention on carbon observing systems as well, climate indicators, the need for green infrastructure, all of these are very integral to the science needed for economic, social, and ecological resilience, as I started at the very beginning. So let me close by talking about what have we learned. Well, I showed you some of the scientific results, social sciences, physical, biological, geochemical, but there's some other important messages, and I didn't want to give you just sort of a traditional kind of approach to what we've learned. There are some key messages that are coming out uniquely and specifically out of the Gomery-funded research. And the first is transparency. And my hat's off to the folks in the federal agencies, in the state government, in the universities who recognized early on the need for transparency, availability of data, balanced with the quality assurance, quality control aspects of how we make that information available. It goes without saying that resources are critical, and obviously dollars is the first thing that people think about when you say resources. My message is broader than that. Resources in terms of, do you have the observational capabilities? Do you have the scientific skills? So preparedness is part of this. Monitoring has got to be in place. We cannot get the baseline information after the fact. We have to have sustained monitoring and observation systems. We have to know what the skill sets are. We cannot scramble and say we need one of these and two of those. We should probably be doing extensive numbers of desktop exercises to determine what that expertise is. And then let's talk a little bit about the best available science. You hear that a lot. I hear it a lot in Washington. What I think is best available science, I guarantee you, is probably different from what you think is best available science. But at the very least, we should be in a place that fosters the kind of robust discussion based on the facts that allows us to understand what the various certainties and uncertainties are associated with the scientific results that we seek. And obviously, it is wonderful forums like this conference and the careful scientific leadership that we've seen in groups like Gomery that will ensure that we all are the beneficiaries of the best available science. Thank you very much.